All right, good morning, good afternoon, or good evening. My name is Tyler, and today we have another project here within Cisco Packet Tracer. Just like every project, we do need an objective. Without an objective, we won't know what we're doing. And if we don't know what we're doing, then we won't be doing anything at all. So today's objective is to interconnect multiple routers across separate networks using static routing. We'll then apply route summarization to reduce routing table size and improve overall network efficiency. So let's go ahead and get started. We are here within Packet Tracer with a blank canvas. The first thing we'll do is grab our routers. We're going to be using 3 routers here today. And since these are all the same device, on layer 1 we will connect them using a copper crossover wire. Just a quick tip. I like to keep everything uniform, just to understand what's going on, because there can be a lot of different configurations and things going on here within Packet Tracer. What I'm speaking about is the labels that are automatically given to each router once we connect the ports, showing that this router is Gigabit Ethernet 000. Router number 1, both of its ports are being used because it's in the middle of these two. The way that we can turn that on is by heading here to preferences. I know it's a different way to get there on Windows, but wherever you find your preferences at for Packet Tracer, it's going to be this box here that we'll always keep checked. Always show port labels in logical workspace. Like I said, it just keeps everything together, uniform and neat, and prevents any confusion going forward. So we'll continue with that labeling here. First, we're going to create a diagram to demonstrate our two networks. For that, we're going to use the ellipse tool. Go ahead and choose a fill color for the first one. Let's do blue. Go ahead and draw that here, showing that these two routers are part of this network, and then we'll do the same on this side with a different color. We'll do green. Alrighty, so as you can see, we have our 3 routers. Router 0 belongs to this network. Router 1 belongs to both. And 2 will belong to our green network exclusively. Let's go ahead and give both of these networks an IP, a network IP address. We'll do a simple one, 192.168.10.0. We'll include the subnet as well. We'll do the same thing on this side, 192.168.20.0. Alrighty. So we have both of our network IP addresses, and now we'll give each individual router their own IPs. We'll head into router 0. Enable configure terminal and interface. Like we said, it's going to be Gigabit Ethernet 000. IP address. Since it is a part of this network, we'll go ahead and use the next host available. That's going to be 192.168.10.1. Don't forget the subnet mask. And we'll run a no shutdown command. So we have that status changed up. Always double check it. We'll go ahead and do show run. And we can see Gigabit Ethernet 000 has an IP and no shutdown command for that specific port. We'll go ahead and do the same for the other 2 routers. Now this router, we will have to assign an IP for both this port that is Gigabit 000 for this network and 001 for this specific network. Same steps enable, we'll do configure terminal, and then we'll do the interfaces. Start with 000. It's going to need another IP address, 192.168.10.2. And a no shutdown command. Once we go ahead and click enter, that should bring these red arrows to green, showing that those two are connected. And there we are. We're going to remain within this router because we need to assign an IP for this specific port for that network. Let's go ahead and exit out of that interface and head back in to get into 001. Since it's a part of this network, it will be the next host available. It's going to be 192.168.20.1. Same no shutdown command. So now we have configured this specific router. Let's go ahead and double check that. So yes, we do have an IP address for both ends. Let's go ahead and label these now before we get to assigning too many IP addresses, like I said, just to keep everything uniform. 168.10.1 with that subnet 192. So this IP will be for this side, and we need one for the latest port that we configured. And for this one, we'll go ahead and label it before we head into the router and actually configure it. It's going to be 192.168.20.2. Interface. Remember, this is going to be interface 000 for this one as well. Assign it its IP address that we have labeled here already. And run our no shutdown command. Alrighty. So we have two separate networks sharing router number 1 that is configured on both sides. Routers 0 and 2 are not. So for us to be able to communicate between each, we need to create a static route. And to do that, we will head into router 0 here. We are going to exit out of that configure interface mode, exit out of config, just so we can demonstrate what is applied currently. We're going to do a command called show IP route. Once we do that, it shows us our local route, but we see that we don't have any static routes configured. So that's what we're going to go ahead and do now. To configure a static route, we do need to choose our destination first. That is what we will apply first. So our destination is going to be this entire network, the network IP for this specific network. Since we're coming from router 0, we want to make sure we're able to reach router 2. So this is the network that we'll apply. That's what will be listed first. And then afterwards, we will need to show what the next hop is, which is going to be typically the gateway to get into this network. Of course, to reach router number 2, we're going to have to go through number 1. And since this is a part of both networks, it won't have an issue doing so. So like I said, I'll go ahead and demonstrate it now. The command is IP route. Excuse me, I need to go to configure first. All right, so we're in router configuration for router 0, and we're going to go ahead and apply that static route. To do that, we will do IP route. What we need to type first is that destination network. So we'll do 192.168.20.0. We also need to add the subnet 255.255.255.0, followed by what is called our next hop, which will be our layover, so to speak. A mentor of mine, that was a way that it was kind of described to me. If you were flying from, let's say, San Francisco to New York, you may need to stop in Chicago first. So that's what we'll have to tell our CLI, which is our next hop, basically our layover destination. And to do that, we will give it the IP address. That IP is going to be 192.168.10.2, since that is the IP for this specific port that corresponds with this network. Once we have that typed in, we'll go ahead and hit enter, and we'll check that by heading back out and typing show IP route. And so there we have it. It shows us now gigabit Ethernet 000 from router number 1, router 0. That's going to be here. To reach this network, which is the green network, 192.168.20.0, it can reach there via this specific hop, this specific IP address, which is coming from router 1. So let's go ahead and try to ping our router on this end from router 0. We'll go ahead and enter. Oh no, we don't need to enter configure terminal, excuse me. We can just type in our command ping 192.168.20.2. That's going to be the IP for this specific router. We'll hit enter, give it some time, and as you can see, it is not pinging. Not pinging because, of course, with that ping command, what that signifies is that there are packets that can go from our router 0 all the way to router 2 and back. So let's go ahead and open simulation mode just to give us an idea of what's going on. We'll go ahead and repeat that ping command. And if we look in simulation mode, it shows that packet is reaching router 1. If we fast forward a bit, it does reach router number 2, but it's not able to travel back. It can only reach that way. And why is that? That is because we have not configured the static route on this end. So we'll go ahead and close simulation mode. All right, so now that we have simulation mode closed, we'll go ahead and configure the static route for router 2 to make it back to router 0, meaning that this network is able to communicate with this network. exit that configuration mode and follow the same steps. Which is adding that IP route. So we'll go ahead and type in IP route 192.168.10.0 with its subnet. And then the next hop, which is going to be this side, gigabit Ethernet 001, this specific IP address. 192.168. Excuse me, let's scoot that over a bit so that you can see it. 20.1. Go ahead and hit enter. Exit to check our work, show IP route, and then you have it. Router 2 does have a static route. It is able to reach this specific network via the router that is shared by both networks. And now we should be able to ping router 0. So let's go ahead and give that a shot. 2.168.10.1. And there we have it, a success rate of 100%. We see our routing table shows both. It is able to communicate with router 1 and router 0. Just to double check, since we are in router 2, we can go ahead and try and ping from router 0 again. We're going to try and ping router 2. And success rate is 100%. So we are able to ping both routes. Now, what we're going to move on to next is the route summarization. Matter of fact, before we do move on to route summarization, I just want to show that we can continue the process, not by making it any more difficult, but just by adding another router. So let's do that first. And then we will configure an IP route for the new router as well to make sure that all 3 networks are able to communicate. So we'll add one more router here. Of course, that same copper crossover wire. Let's grab our ellipse tool to demonstrate this specific network. Let's go to red. Go ahead and draw that out. Let's give it a network IP address, 192.168.30.0. All right, so because we have a new network, router 2 does have another port being used, gigabit Ethernet 001. We're going to give that an IP address and then an IP address for this specific router as well. So let's slide this over a bit so we don't get confused. We'll head into router 2 and give that an IP address for that specific port. Run that no shutdown command. Let's go ahead and check that. Excuse me, I have to head back into configure. All right, so router number 2 here does have an IP address for both interfaces, 000 and 001. We'll go ahead and label that as well because we label everything. 192.168.30.1. And we will give this one an IP address as well. We'll go ahead and label it first. All right, head into router 3 so that we can assign that IP. And run the no shutdown command. All right, so that status has been changed to up. We have green arrows. Now we need to route from 0 all the way to 3. And to do that, we will just follow the same steps. When we enter the IP route, we will start with this specific network since that's our destination. We'll add the IP address for the network, followed by the subnet mask. And then again, we'll have to do the next hop, which is going to be 192.168.10.2, since that is the closest router. We'll go ahead and head into router number 0. And the next hop is 192.168.10.2. Right. Now let's go ahead and check that. All right, so another static IP route has been added that will allow us to access that .30 network via the same next hop, which is the router that's also within its network. Let's go ahead and try and ping to see if we are able to reach router number 3. And success rate is 0%. We are not able to reach router number 3. That is because we do need to add router 2. We are able to get the packets to router 1, and it understands that it wants to make it to this specific network, but we need to add that same IP route for router number 1 so that it can connect here with 2. That is a part of both of these networks. So we'll head into router 1. Right, let's demonstrate it first. So on router number 1, we don't have any static routes that are going to help us reach router 3. So let's go ahead and add that now. 192. Of course, we start with the destination, which is 30.0. And then we do need to add the next hop. So for this specific router, our next hop, of course, is going to be router number 2. We're going to have to do the gigabit Ethernet port that is within this network. So that's going to be this one here, 192.168.20.2. excuse me, we need to head into Configure Terminal. And we can just copy and paste. We'll run that same command. And then we'll go ahead and hit exit. Let's check the IP route again. And there we have it. We do have a static route that is able to reach this network via this next hop. So we are able to get from router 0 to 1, which will get us to 2 and give us access to all three of these networks. But like we showed before, we do need to configure it going back the other way so that packets are able to be sent both directions. To do that, we'll go ahead and head into router 3. We'll let it know the destination network we want it to be is here in this area with this IP address, and the next hop, of course, will be router number 2 and the specific IP that is a part of this network. And we'll exit configuration. Router, exit that as well. All right, IP route 192.168.10.0. And then our next hop, which is 192.168.30.1. Alrighty, so we have that configured so that we are able to send information back this way. Let's go ahead and attempt to ping. We'll show it in simulation mode just so we can have the visual and make sure it is good to go. Let's actually start on this end this time. Exit configuration mode, ping 192.168.10.1. It's going to be this specific router here. And there we have it. We're able to ping. It shows 80%, but of course, if you run it again, then just takes a second to boot up and it's 100%. So what we did here today was configure routes between both directions. We can go ahead and show it in simulation mode through static routing. All of these are on different networks, of course, because they have different network IPs, but that doesn't matter because they're all able to communicate with each other through static routing. Let's say, like I said, let's go ahead and ping the other end and show it in simulation mode. .30.2. Able to ping the other way perfectly. Let's go ahead and open up simulation mode. Let's run that again so that we can watch it. Go ahead and hit play. And we're seeing how the packets traverse throughout the network. All right, we see it heading back as well. So we are good to go. All right, let's head back into real-time mode. And lastly, what I wanted to cover was the route summarization. So for route summarization, instead of entering each IP, each network IP, we can go ahead and summarize using subnetting. so that we can reach any network that begins with the first two octets, 192.168, no matter if it was 10, 20, 30, 40, 50, 60, 70, so on. And so to do that, first we will head into router number 0. We're going to run a command that is called show run and include route. So let me go ahead and demonstrate that for you. It is similar to the regular show run. We'll go ahead and put that bar there. And once we do that, we can type in include route. So that's gonna isolate the routing information. Once we put the bar and then add include route, you can run this command to give you different information from the CLI, but right now we're just focused on the route, the static routing paths. So once we run that, we can see with router 0, the IP is able to be routed to the 20.0 network as well as the 30.0 network. And it uses that same next hop to reach both. If we want to condense this and just make it a little bit more efficient, what we can do, I'll show you now, is change the subnetting from that class C to the class B and remove those digits from the third octet so that it will be able to reach any IP that begins with 192.168. To do that, what we're going to have to do first is remove these two routes. So we'll go ahead into configure terminal and we'll do no IP route, and we can just copy this first one that gives us access to that 20.0 network. Go ahead and paste that there. So this one has been removed, and now we will remove this one as well. We'll copy that, type in no IP route, and paste it. So we've just removed both routes. Let's go ahead and check that by exiting configuration mode and typing in IP route. Oh, excuse me. Show IP route. So if we look at our routing table, those static routes have been removed, but we can add them back by summarization. So we'll go back into configure terminal. And what we do to add those, like I mentioned before, is to change the subnet. So if you understand subnetting, this will be, you'll be able to understand this as well. If you're having a little bit trouble with subnetting, this may be a little bit confusing for you, but the more practice that you get with subnetting, the easier it gets, and things just kind of start to make sense over time. All right, so excuse me, we did remove those two static IP routes. We're checking here the IP route table, the routing table within router 0 here. And now we will create a new route so that we are able to reach each network like we were before. We're just going to do a little bit of changing to the subnetting just to make it just one route instead of it having two individual ones. And to do that, we will go ahead and enter configure terminal. We'll enter this specific port because this is still where we're beginning. Interface, gigabit Ethernet 0, 0, 0. So we're in that specific port now. What we're going to type is IP route 192.168.0.0, followed by the new subnet. And then we still do need to enter our next hop. We always need to enter that middle destination so that we can communicate with each of the other networks. It's going to be 192.168.10.2. Alrighty, so now let's go ahead and exit. I'll show you what the new routing table looks like. So we're going to do a show run with the bar and followed by include route. And now instead of two individual routes, we have just one route with a different subnet and different network address that's able to communicate with each of these networks. That is what's called route summarization. Just to shorten it, because the less configurations, the better. Just keeps everything neat, easy to read, a little bit more uniform. And our final action, we will go ahead and ping again to show that this is still able to reach each of these networks. So we are still within router 0. We'll type in our ping command 192.168.30.2. We want to reach this end from this router. All right, and there you have it. Success rate is 100%. So what we did here today was configure 3 different networks using 4 routers, all of them within different networks, but they were all able to communicate with each other through static routing. Static routing is basically just manually entering the networks that you'd like to reach that are not a part of your specific subnet. Different from dynamic routing, but I'm sure we'll have a project on that soon. I want to thank you guys for watching, following along, and I'll catch you next time. Thank you.